Okay, so here this is going to be one of those, we're doing a confidence interval for proportion. So our x value is the number of like, um, kind of like it's binary. So it's either going to be yes or no. And in this case, it's either a critical strike or not. And so it looks like there were 239. And then N is going to be the number of potential attacks, which in this case was 598. And then that will allow us to find P hat. And so P hat's just going to be the ratio of successes over the total tries. So 239 divided by 598. And let me get my calculator here. All right, let's see. Where did it go? There it is. So let's see. 239 divided by 598. So we can round that to pretty much, I think, zero point 0.4 is fine. Let's just round that to 0.4. So 0.4, and I'll add a 0 onto it to make it clear that we rounded. So that would be the p-value. And then what you have to do from here is you're going to have to find the margin of error, which is the critical value times the standard deviation. So let's see, our margin of error is going to be equal to the critical value times the standard deviation. And so we need to go ahead and find standard deviation real quick. And then we can also talk about looking up the critical value. The critical value is going to come from the confidence interval of 95%. Okay, so for the standard deviation, what that's going to be is the square root of basically a success, which is 0.4, times the complement, which would be 1 minus 0.4, which would turn out to be 0.60 if you were to calculate that, and then divided by the number of values in the sample, n, which is going to be 598. So let's go ahead and put that in the calculator now. So let's see, the square root, and so you have to be a little careful the way you, well, I think we'll be fine actually. Sometimes you have to be a little careful on how you put it in, but this one actually should not give us any problems. And then divided by 598, close it. So we're going to get about 0.02. That's probably good enough because there's a bunch of zeros after it. So 0.02. Okay, so that is our standard deviation for our sample. And so then, so I'm going to put a little s there just to indicate that it's from the sample, not the population mean. And so then the critical value is going to be the 95% right there. And so there's a couple different tables we could use to look that up. The easiest one, even though this isn't a t-distribution, the confidence intervals are listed on the t-distribution. So I'm going to go ahead and grab that real quick. Okay, so here's my t-distribution. It's been written on. But so if we go down to the bottom, you can see confidence interval right there. And we're actually using the z. Okay, so it has the t-distribution, but it also has the z-scores right here. So we're looking at the 95% confidence interval. And so that critical value is going to be 1.96. So let me go back to, here we go, 1.96. So my critical value is going to be 1.96. Okay, and so let's go ahead and do that. So we're going to do, let me change colors. So we're going to do 1.96 times 0.02. So let's do that in the calculator. And then afterwards, at the end, I am going to show you how to just do this all in the calculator because there is a way to do it that way also. All right, so let's see, 1.96 times 0.02. And so we get 0.0392. 0.0. See, I think we're probably fine with 0.03. Yeah, I'll just put the whole thing. Or no, it's exact. 0.0392. Okay, so then what you're supposed to do is to find that value. you're supposed to take the p hat value and add it and subtract it, that margin of error. So you're supposed to take p hat and you're supposed to add and subtract your margin of error, and that's what you're going to squeeze this between. So p is going to get squeezed between 0.4 plus 0.0392 and then 0.4 minus 0.0392. And so let's see, let's go ahead and do that real quick. And then, like I said, I'll show you in the calculator how to put all this in and run it in the calculator, and we'll compare and see what it looks like. So 0.4 minus 0.0392, and so we get 0.036. And so apparently, I guess 2 decimal places are going to be fine. So I'm going to just do 0.36, and then so basically it's 0.04. So then I'm going to add that to it on the other side right here, and so that would give me 0.44. Okay, so let's run this through the calculator real quick just to see if everything looks good. So what you can do is if you go to stat and go to test, there we go. We're looking at the you want the interval one. Okay, so lately in class we did what we did on Thursday was the proportion z-test, the one proportion, and then we also were doing those z-test and t-test and all that kind of stuff. But this is the interval ones are right here for whenever you're talking about a z or a t. So in our case, it's a z, and the reason why is because actually, hold on, the standard deviation. Well, it doesn't matter because there are so many, so it won't make a difference. Okay, so here we go. So we're going to go to stat. Then we're going to type in our standard deviation. Let's see, which was 0.02, so 0.02. And then our x bar. Hold on. Let me double check. I need to make sure I'm in the right spot. Okay, I apologize. So where I was, that is something we've done, but actually I was in the wrong spot. So I'm sorry. There's a bunch of these different ones. All right. So we had the z-test, the t-test, then we had our proportion z-test that we did this week. Then we had the z-interval and t-interval, which, yes, we do those, but that's not for proportions. I needed to keep arrowing down, and it's right there. It's the one proportion z-interval right there. So I'm going to go ahead and click on that. And then, so there's really not much you have to put in here. You just put in what x was, which was 239. Then we put in the number of observations, which was 598. And then your confidence level, it defaults to 0.95, which is a 95% confidence level. And so in case it differs, you may have to change that, but it's what we want for this particular example. And then we just go to calculate, and there it is. And so you can see that if you were to round 2 decimal places, it matches what we have right here, right? So, all right, I hope that helps. And if you need help on any of the other parts, just feel free to reach out.